Welcome to episode 18 of my calculus series. Today, we're diving into area and definite integrals. But before we get into it, if you're enjoying these episodes, a like, follow on TikTok, or subscribe on YouTube would really help me keep making more lessons like this. Alright, let's get started. What is a definite integral? We define a definite integral using a continuous function, f of x, over a closed interval from a to b. We write this as the integral from a to b of f of x dx. This represents the net area between the graph of f and the x-axis, from x equals a to x equals b. Definite integrals as limits. We can also define definite integrals as the limit of a Riemann sum. We say, the integral from a to b of f of x dx equals the limit as n approaches infinity of the sum, from I equals 1 to n, of f of x sub I, times delta x. Where delta x is equal to b minus a, over n, and x sub I is a point in the ith subinterval. Fundamental Theorem of Calculus. This theorem allows us to evaluate definite integrals without Riemann sums. If capital F of x is an antiderivative of f of x, then the integral from a to b of f of x dx equals capital F of b minus capital F of a. Example 1. Let's find the area under the curve f of x equals x squared, from x equals 1 to x equals 3. We compute the integral from 1 to 3 of x squared dx equals open bracket x cubed over 3, close bracket, from 1 to 3. That becomes 27 over 3 minus 1 over 3, which equals 26 over 3. Example 2. Now, let's find the area under f of x equals sine x, from x equals 0 to pi. We write the integral from 0 to pi of sine x dx equals negative cosine x from 0 to pi. That gives us negative cosine pi minus negative cosine 0, which becomes 1 plus 1, and the total area is 2. Example 3. Let's find the area between f of x equals x squared and g of x equals x, from x equals 0 to x equals 1. We subtract the functions inside the integral from 0 to 1 of x minus x squared dx. That becomes x squared over 2 minus x cubed over 3, evaluated from 0 to 1. We get 1/2 minus 1/3, which equals 1/6. Example 4. Find the area between f of x equals cosine x and g of x equals sine x, from x equals 0 to pi over 2. We integrate the integral from 0 to pi over 2 of open parenthesis cosine x minus sine x close parenthesis dx. This equals sine x plus cosine x, evaluated from 0 to pi over 2. At pi over 2, sine is 1 and cosine is 0. At 0, sine is 0 and cosine is 1. So, total is 1 plus 0, minus 0 plus 1, which equals 0. Since the graphs cross, the net area is 0, but if we wanted total area, we'd split the interval and take absolute values. Example 5. Evaluate the integral from negative 2 to 2 of x cubed dx. Since x cubed is an odd function, and the interval is symmetric about 0, the integral equals 0. That's a property of odd functions over symmetric intervals. Example 6. Now let's evaluate the integral from negative 3 to 3 of x squared dx. X squared is an even function. So we double the integral from 0 to 3, 2 times the integral from 0 to 3 of x squared dx. That gives 2 times open bracket x cubed over 3, evaluated from 0 to 3. So that's 2 times 27 over 3, or 18. Example 7. Let's evaluate the integral from negative 2 to 2 of absolute value of x dx. We split the integral from negative 2 to 0, absolute value of x is negative x. From 0 to 2, it's just x. So we compute the integral from negative 2 to 0 of negative x dx, plus the integral from 0 to 2 of x dx. That gives negative x squared over 2, from negative 2 to 0, plus x squared over 2, from 0 to 2. After evaluating, we get 2 plus 2, which equals 4. Summary. Here's what we've learned. Definite integrals represent net area under a curve. They are defined as the limit of Riemann sums. You can evaluate them using antiderivatives via the Fundamental Theorem of Calculus. And that wraps up episode 18 of our calculus series, Area and Definite Integrals. If you found this helpful, hit like, follow for more, or subscribe on YouTube to catch the full lessons. Thanks for watching, and keep practicing. See you in the next one.